to the link that I provided. I can also copy it into the chat now. There's a Git repo that has 3 different classes. One is Java, one is JavaScript, and one is Python. As it says on the slide, they are all identical, just different because they're different programming languages, but the problems associated are the same. We'll talk a little bit more in around 15 minutes about what this is going to look like, but it will help if you prepare yourself now. I recommend if you have an IDE installed, that's definitely the best way to go about what we're going to practice for this problem solving, but you can also use print statements. If you don't have a repo, an IDE readily installed because you are me last year when I only had an IDE on my work laptop, we also have some options for browser-based. So this one that I'm putting in the chat now is good for JavaScript. Thank you to my colleague Kyle for that recommendation. And then here's one for Java. And finally, one for Python. If your programming language of choice is not one of those 3, I apologize. 3 was my limit.
Okay, it's time to start. I think more people are joining in. Yeah.
As I said, we have plenty of time.
Yes.
Hi to everyone who's joining.
Okay.
I think when people are joining, you can see the prior chat, which has, as I was just describing, but we have more people joining, the GitHub link for the prompts we'll use for problem solving, as well as a series of browser-based compilers. As I said, definitely easier if you use an IDE. I'm going to be demonstrating using Eclipse, but if you don't have one installed for whatever reason that might be, use one of the browser-based ones. They'll work just as well. You'll just use some print statements.
Okay, so let's start. I think 50 people have joined now, around 50, right?
Yeah, let's go.
Okay, so hello everyone. So sorry for the inconvenience. My camera is not working today, so I'm really sorry for that. But thank you all for joining today's session, problem solving like a pro, applying the scientific method to P1 investigations. Please welcome our beloved speaker, Kelly Anlas. Kelly is an engineering manager at Stash, working with a team of engineers who develop and support the bank platform. Previously, she spent nearly 5 years as a backend software engineer and then a dev manager in the algo trading space, where she specialized in developing customer-facing analytics in real-time systems. Additionally, Kelly is an avid softball player. She's a theater goer, and she's the director at Women Who Code, New York City. On to Kelly.
All right, thanks, Surya. Welcome, everybody. Thank you so much for joining. Before I go to the next slide, I'm going to give one more reminder that this is a great time to go to the GitHub link here that you'll be able to get your problem-solving prompt for approximately 15 minutes from now when we get to the true workshop portion of the event. We will also share this link multiple times, so you'll get it, but it's always a good reminder. So welcome to this workshop, Problem Solving Like a Pro. I'm so happy you're here. This is probably going to feel a lot different from any of the other sessions that you attended. Very casual. We're going to have some fun. I'm going to talk for about 15 minutes, and then we're going to have some interactive problem solving to do. So you may be asking yourself, why am I here in this session, not on this earth? I am not ready to answer that question for you. But in this session, maybe you're an engineer who's tasked with solving production issues, also known as P1s. Maybe you're a developer who wants to feel more confident on the spot when you're being asked questions, asked to solve problems, tasked with finding answers. Or maybe none of the above, but you're just looking to challenge yourself to problem solve smarter. If any of the above apply to you, you're in the right place. Otherwise, you might be in the wrong class, and let me know if you need a syllabus. So here's what to expect from our hour together, which is going to go by very fast, I promise. I'm going to talk for about 5 minutes in the intro. We're going to talk for about 5 minutes about the scientific method and the market, the stock market. And then we're going to work through a series of scenarios. They're progressively a little bit harder. They'll be fun, I promise. And at the end, we'll do some takeaways, and we'll also leave time for some Q&A. And hopefully at the end, your problem solving is a little bit more structured than this lovely GIF that you see in front of you. So why me? Who am I? I'm Kelly Anlas. My pronouns are she, her, and hers. As Surya said, I'm an engineering manager at Stash. Stash is a personal finance app where you can do investments and banking all from your phone or a website. I've been there for close to 6 months, which is a little bit crazy. Previously, I was at a company called Clearpool Group, which was then acquired by the Bank of Montreal. Clearpool developed trading algorithms. So if you ever watch CNBC during the day, no one, just me? Okay. The trading algorithms are the things that traders employ that allow them to buy and sell massive quantity of shares based on computer decision making. So whereas like you and I as traders might go on and say, oh, Apple's trading at $200, a trading algorithm would say, Apple's trading at $200.02, but I'm going to wait until it drops to $200.01. Because the biggest deal with these trading algorithms is what is your performance, or how much better am I doing compared to the rest of the market? You know, you're paying this premium to use these algorithms. One of the most important parts of our system was being able to demonstrate to the brokers that performance. And that was a whole team, a team which I ran for nearly 5 years. I called it the customer-facing analytics team. And all of the things that we're going to talk about today are based on that experience, including the problem solving that you're going to do in front of you. In addition to all of that, I'm also one of the directors for Women Who Code NYC. As I say, it's my absolute favorite extracurricular. I love doing it. I love working with all the leads. I love putting on events. I'll remind you again at the end of this session to come and check us out. Would love to see you more there. And yeah, there is a picture of me playing softball at my charity softball tournament. All right, what should I get out of this? First and foremost, a case for having a structured problem-solving process. Secondly, a problem-solving strategy on which to iterate. And finally, a fun, hopefully, an interactive workshop to practice said strategy. All right, are we ready? Let's go. All right, why do I need a problem-solving strategy? So I want you to think back to the last time that you as a developer, or in whatever role you might have, were tasked with solving a problem. Did you have a directed approach? Did you choose to look at things in depth versus breadth? Were you able to account for all of your time? If someone had asked you to pass off the efforts of your investigation to another person, would you have been able to do it? And this is going to sound a little cheesy, but like, how did that make you feel? How was that process for you? Was it empowering? Did you feel like you were making progress? Or did it feel hopeless? Did you feel like you were falling down a black hole, like in our GIF? So the reason that I think that a problem-solving strategy is incredibly important is, one, it allows you to focus your efforts. So anytime you have, and I can tell you this happened more times than I can possibly remember, someone would come over and say, something's wrong. It's like, okay, great. Please tell me more. These investigations were never usually easy. They involved a lot of complicated problem solving. They involved being able to focus your efforts. So knowing where your time was better spent and the things that you could push off or at least prioritize to look into later. You're able to find decisive answers faster. And note that I say decisive answers and not necessarily like the be-all, end-all answer. I do and have always believed that these sort of investigations, whether they be P1s or just complications in your own code, are difficult. That's why this is hard. That's why we're talking about it. But by having an iterative problem-solving process, you're able to loop through that start from like, what am I thinking about, to what are my answers faster. And therefore, you're accumulating information that you can then backtrack through. And that's really important, again, to my earlier prompts, if you need to pass that information off to somebody else, or even if someone's just asking you, you've been looking at this for 90 minutes, what have you found? Problem-solving strategy will help you answer that question. And finally, it helps you to avoid these rabbit holes. So the problem-solving strategy that I am going to advocate for is based on the scientific method. And because science class was first period for me at 7:30 a.m., I also need a refresher. So remind me about this scientific method. You may recall it involves an iterative process that starts with the top with your observation. So you have an observation. In science, it's usually something you can observe in nature, in a body, whatever your discipline might be. You make a hypothesis, something that you are going to prove to be true or false. You drive an experiment that allows you to prove said hypothesis, true or false, and you come to a conclusion. So let's take that and link it to software development. So observation, that's the data science, or your CTO comes over and says, something's wrong. Okay, what has been reported? What is the evidence that something is wrong? If you're looking at a calculation, any sort of logic or math, which we will be shortly, how do you know what the correct answer to something is? Looking at the code, what do you know about the service in question? Is it something you've worked on before? Is it something that's new to you? What is its overall place in your ecosystem? And kind of most importantly, what recent changes have been deployed or made? I include this one because this was, again, an experience at Clearpool and everywhere, which is a lot of times when you have an issue, it's due to a recent change. And it's not always the most obvious what changes will impact everything else downstream, although the better you get at thinking about those things ahead of time, the stronger an engineer you're going to be moving forward. But I think of this as like your Occam's razor answer. Always check first to see like, what are the recent changes? So all of that goes into your observation. Any information you have in front of you that can help you move towards a resolution. After that, you come up with your hypothesis. I think that something, and I will know if I am correct when something else. Again, the B part of that situation, I think, is one of the most important things, because I feel strongly that if you don't know what you're trying to find while you're investigating, you will never find it. It's totally an expected part of the process to have an hypothesis that gets proven incorrect. But again, the key point is, how will you know? You do an experiment. In our case, this is going to be a debug that either proves or disproves your hypothesis. In real world situations, you might be able to do remote debugs, which were always my favorite. You might be able to replay through a series of events. If you have an event-driven architecture, you might be able to recreate the sequence of events that brought you to the bug that you observed. There's a million different ways you could do this. Again, today we'll do debugs. And finally, a conclusion. And as I mentioned, if you are concerned about problem solving or want to see yourself advance as an engineer, this ability to both summarize and share and even pass off the results of an investigation is really important. So by creating this problem solving strategy where you're frequently iterating through and coming up with that conclusion that you can share, you'll be able to prove both to yourself and to anybody else who asks or to whom you need to be accountable what the process and conclusions from your investigation were. So let's try it. We're getting to the workshop portion, everyone. Oh, wait, first, the stock market. Let's level set. For anyone for whom the stock market is a bit new, don't get scared. I promise this is going to be very straightforward, but let's just talk about it at a really high level. The stock market allows anybody with the proper funds to invest in publicly traded companies. You get fractional shares that give you absolutely no rights. Buying shares of Tesla does not make you Elon Musk. However, the best part of investing in the stock market is you can buy something like, I don't know, Tesla at say $250 and sell it at some point down the line for let's say $500, not a real example, and you get to net the profit. You get to take that back with you. So stock market, really interesting topic. I could talk about this all day, but I won't. So for today, our prompt, the question that we're going to solve with our code is how much cheaper were our trades than the rest of the market? All right, so both for regular traders and for these big stock trading algorithms, we would always use performance metrics to determine how successful something was. In this case, we're going to use price improvement. Said another way, given the current market, how good was your price? This is stuff straight from my algo trading days. How do we define that current market? So for the current market, we use a quote. A quote defines or demonstrates for you what the best buy and not the store and the best sell prices are. So that's the highest price that someone's willing to buy at and the lowest price that someone's willing to sell at. The difference between those two values is our current market. So again, a quote defines what everyone else is doing. You want to do better than everyone else. All of our trades are going to be buys just for the sake of convenience. So for us, our price improvement calculation will always be best sell price minus our price. The difference between the two of those is your price improvement. If you think this is interesting, check out Investopedia. It's a fantastic resource for learning more about the stock market, as is getting a job in the algo trading industry. All right, so with that 15 minutes, you have now graduated and you are welcome to be employed at my Kelly's trading desk, of which there are currently 98 employees. We trade exactly $0.00 in assets under management, but it's very exciting. We have lots of great benefits and okay, just kidding. We have some issues. It's time for all of us to go to work. Here we go. So this is the same slide from before. If you have not already, please go to the GitHub link shown. You will find there 3 classes. One is Java, one is Python, one is JavaScript. Again, all of them are the same. They're obviously written in different languages, but the problems that you'll solve will be the same. If it matters, I'm going to demonstrate in Java, but you should pick the one that you're the most comfortable in. I do recommend putting it into an IDE, but if you need to, you can use print statements instead. And there are, thanks Mackenzie, you're the best. There's a bunch of pinned links in the chat that allow you to use a browser-based IDE if you don't have one downloaded. So that's probably your easiest way there. I'm going to take a brief moment for anyone who needs to get that, take a sip of water, and then we'll move on. All right, so one more time, all those links are available. One more time, scientific method, along with a fantastic GIF. Observation. So your observations are going to be anything you can find in the code, anything that I've shared with you. All of that information is part of your observation, as well as the print statements that we'll see. Come up with a hypothesis. Know what you're looking for. Know what you're trying to find. Your experiment is your debug, and come up with a conclusion. And with that, we're ready to start solving. So I'm going to walk through the first problem so I can also show everybody a little bit about this code itself, just to give you an introduction. If you'd like to try, go ahead and solve them on your own. Please feel free. This is not school. I am not your professor. This is a choose your own adventure kind of workshop. But let's walk through what you can find in this class and how it works. So I'm going to start actually with the run method. Again, this is the Java version, but your Python and JavaScript classes will be shockingly similar. We're going to run through a series of 3 scenarios. Each scenario is breaking. So if you do not pass the first scenario, you will not go to the second and third ones, just as an FYI. Inside run scenario, this is just a lot of bookkeeping. So I wouldn't necessarily worry too much about it. But essentially what you're going to do is get this price improvement and get a result. And then you're going to check to see if these 2 values are correct. So this is the total price improvement, which is the one that we've been talking about. Quantity is just the number of shares that you traded. So it's the sum of all of the shares in your buys. So again, that price improvement, you're going to spend a lot of time in that method. Get familiar with it. One other thing I want to call out is just the quotes and the trades. So remember, quotes are the market. They define what everyone else is doing. Trades are you. They define what you have done. And remember, what we're looking for is how much better did I do than everyone else? One other thing, these numbers up here are the correct answers to each scenario. I promise they're correct. You could just change them to make your code pass, but that's not the spirit of problem solving, is it? So if I go ahead and run this class, I see that I'm starting scenario 1. I've got a bug. I see that the correct total quantity is 550. I actually changed the terminology. Yours is going to say expected and actual. Same thing. So the correct total quantity is 550, and my result is 700, which is clearly wrong. There's also a problem with price improvement, but let's start by looking at the quantity. So where do I check my quantities? Now, since I already know this, I'm going to get this answer pretty quick, but the rest of them are going to take you probably a little bit longer. I'm going to come into this get price improvement method. You'll see here that we keep some totals, we iterate through our trades, we find a quote, we calculate price improvement, and then we get some running totals. So my theory is that something's going to be wrong with one of these trades, and I'm going to add in a debug point here. I'll remove that one. And I'm going to see what we get each time we iterate through this loop. All right. So let's look at these trades. Trade 1 looks good to me. Trade 2 looks good. Trade 3 also looks fine. Trade 4, cool. Oh, we hit trade 4 twice. That's a bug. And I'll share that too, that the things you're going to find in this code should be fairly obvious what's wrong with them. So I see that we got this twice. I'm going to look and see where we set this trades. It's a class level variable, so I'm going to scroll up to where I defined them. Oh, here we go. This.trades. And I found our first bug. We have trade 4 in here twice. So I'm going to kill this debug. I'm going to run this again. Fantastic. We passed scenario 1. All right. So with that, it's time to switch back to you. So here's how this is going to work. Because I am terrible at keeping time, instead of keeping time, I play music. And because this is going up on YouTube, I cannot play music over the event. But instead, if you'd like the curated experience, I just shared the Spotify link in the chat. You could also look up Anlas, no spaces, no caps. It'll be the only one that pops up. It's Anlas workshop playlist. So you're going to have the time of 3 early 2000 songs to solve scenario 2. There's some information on here. I'll give you some hints as well. In the meantime, if you have any questions, please feel free to put them in the chat. I will try to answer any of them that make sense to answer out loud. And I will also be giving you hints in between songs. So with that, I'm going to click play on my playlist. So my music is now going, and we are in our first song. And your first hint, if I can find it, is price improvement should never be negative. As I said, feel free to put any questions in the chat. But with that, I'm going to take another sip of water and let you get started. just as a fun little hint of something, not to do with your problem solving, but just in general, I love to use music to keep track of things. If I'm doing a Women Who Code event, not the conference, but one of the usual ones for the NYC chapter, and I'm sending people off to do things, it's just, I immediately stop paying attention. I joke that when I'm sending people off, it's 10 minutes, but it's 10 minutes of Kelly time, which is anywhere between 7 and 12 minutes, depending on if I get distracted. And instead, using music really helps to keep you on track. I do this in events too, or meetings at work. If I'm hosting something for the other engineering managers and I want them to think about something for a given period of time, I'll give them the same, hey, we're going to use 3 90s pop songs to brainstorm. I would also recommend using it if you do any take-home assignments for any job interviews. It's a great way to just, again, remind yourself of that, the passage of time. Or when you're doing an investigation, it's a great way to keep reminding yourself to not get lost in a rabbit hole. I think by having the passage of time be clocked by songs, really using it to your advantage, you're able to pull yourself back and ask the really important questions like, is what I'm doing working? Does it make sense for me to continue in this vein, or should I try something else? I think that's one of the hardest things that I've seen engineers have to deal with, is that break between I want to keep moving forward because it feels like I'm making progress, and acknowledging that you have that like sunk time already and it makes sense to switch your strategy to do something else. All of these songs are just excellent spin songs as well. All right, your next hint, we're in our second song. One of the inputs has a bad value. I think I also saw earlier, I think Stephanie was the one who posted it. If you find any like true issues in your code where you're not able to move forward on something, please feel free to tell me. This is the first time I'm doing this for a conference, although thank you to my guinea pigs, Sana and Kyle, for going through this first. It was a little bit of a Goldilocks and the Three Bears situations where the first time we went through it, this was entirely too hard. And the second time we went through it, it was entirely too easy. So hopefully we found a good middle ground. I did write this in Java because I'm a Java engineer. So that's my happy place. And then I translated it into Python and JavaScript. So if there's anything funky in there, you can just write it off as me not really understanding the language. But if you want to give me hints on how to improve it, I would absolutely love to hear them at any point. We're about halfway through Brittany now. I'll add another thing for the problem solving. If you're on the faster end of the spectrum with solving these, which a lot of you are going to be, you'll find that there's usually more than one way to solve these. And I recommend that you find a programmatic solution. All right. Don't want to ruin the end of the song, but we are coming up towards the end of it. And I'm ready to give the next hint, which is more of a, puts you on the right track. If you haven't already, put a breakpoint in get price improvement after the price improvement per trade is set and see when it hits a negative value. Just so I can get a sense of where everyone is, if you are already done or as you finish, or if you're just, listening along but not in the mood to problem solve right now, share in the chat something that makes you happy. Debugging, pizza, backpacking, my dog, cats and sunshine, travel, all great options. One for me this morning is that moment in The Conjuring 2 where Patrick Wilson pulls out a guitar and starts singing and you remember that he's actually a classically trained musical theater actor. Beautiful moment, highly recommend. See a bunch of my friends in this chat now. Hi to everybody. Phoenix, you're approximately 4 or 5 minutes ahead of me. We do have an In the Heights song in the second half of the problem solving. So I'll give one last hint. I saw a request for one. If you haven't already gotten it, is if you look for a zero value in the quotes, you should ignore anything with a zero value. Got about 1 more minute. And yes, I will be showing the answer, so everyone feel free. But also keep at it. Resiliency is one of the most important parts of problem solving. So being able to keep questioning, keep thinking about an answer, that's one of the most important parts. And yes, there's still more issues. So. I think I mentioned this already, but I'll mention it again, that these are based on real things that I had to solve for in the algo trading industry. Things such as zero values. I'll show you in just about 12 seconds where I would put the solution to this, and then we can move on to the next one. All right, I'm going to pause my playlist. So if you're playing along, that's the right place to pause. If it lets me, there we go. All right, so scenario 2 review. So as I mentioned, the problem with this scenario was that there was a zero in one of the quotes. A good place to check for this is I'm in the get price improvement method. I'm going to put a breakpoint after price improvement per trade is calculated. This might be a little, if you're not used to doing a conditional, I wouldn't worry about it too much. There's only 4 trades, so you'd go through a loop pretty fast. But I'm going to check to see only where price improvement per trade is less than 0. I'm going to debug. All right, so I see here I now have a negative price improvement, which is impossible. You can't have negative price improvement. Something is wrong. I'm going to look at my trade, just make sure everything looks good. It's a buy. There's the price, the quantity. Okay, well, it looks good. And I'm going to look at the quote, and I see our issue. Nobody's selling any stocks for $0. We would not be currently doing a workshop if they were. So we know that this is the issue, or at least I'm reassuring you that this is the issue. And as I mentioned, this is something that we would actually deal with when you're working in the stock market. A lot of times your what we would call market feeds, which define things like quotes, as again, like the quotes are everything that's happening for everybody else. Some of the data would come in bad. And one of the things you had to do was put in allowances for it. So either if a value was 0, if the buy price was higher than the sell price, that's what's called a cross market. You just throw that out. So anytime you have bad data, at least in these scenarios, we toss it. So just one more time, I put in here while I'm iterating through these quotes. This is also someplace you'll spend a little time in the next scenario. If there's a market sell price of 0, I'm just going to skip this one. So this should be our answer. I'm going to go ahead and run. Fantastic. We passed scenario 2. I'll also copy this into the chat if anyone wants to just grab it for yourself. The formatting, formatting is okay. You might need to change it again for JavaScript or Python, but that's how you pass scenario 2. All right. Please feel free to put any questions in the chat. I'm going to start us off on scenario 3, but I'm happy to answer them as soon as we kick off. So, all right, stretch it out. I know that was probably hard for some people and it was probably easy for others. So hopefully that was gratifying in some way. Take a minute, and if you're practicing along with us, just give yourself like a, hey, this is good. Problem solving is hard. These are not intended to be easy, and you want to be challenging yourself. So the fact that you are is fantastic. Embrace the Moira, and let's get ready for scenario 3. All right, so once again, we have timing kept in music, which is for Broadway show tunes. Hints will come between songs, and your information is up there. I'm going to go ahead and click play on my playlist, and off we go. Once again, please do put any questions in the chat, and I will try to answer any that come up. First song in this half of the show is Waving Through a Window from Dear Evan Hansen, movie of which is coming out later this year. Oh, I didn't give you the hint. It's not a great one. So the shares traded is correct. Price improvement is no longer 0. Something else is wrong. This probably goes without saying, but the reason we're doing musicals is that I have a deep, abiding love of musical theater and all things performing arts. So remember, as you're starting to think about this, if you haven't already finished it, which is a little bit of a joke, think about all the things that you have in front of you. Look at your observations. Look at the code. This is actually, if you're finding this challenging, it's a good situation to practice for, because a lot of times when you're problem solving in a real world scenario, you're looking at 1, someone else's code, 2, someone else's code that might not necessarily be the cleanest or have the best comments or make the most sense to you. You're under a bit of pressure. I know this is fake pressure because you're not interviewing, I'm not your boss. This is just really for fun. But there's music playing, there's someone talking to you, so there's a little bit of that stress going on. And it's it's good to work at this, like, what information is in front of me? How can I learn about it? And again, how can I use my observations to generate a hypothesis that I can then prove true or false? I think that's especially important as you're going through and understanding what's going on in this code to be able to start coming up with your theories as to why it might be broken. And I will also say again, as we're nearing the end of our first song, if you do find the scenario, you find the issue before time is up, I encourage you to find a programmatic solution. And if you find a good programmatic solution, I encourage you to think about what a really good programmatic solution would be. And this one does have one. All right, song number 2, as I already spoiled, is from the In the Heights cast recording, movie now in theaters. I'm planning on watching it later today. Fantastic song. Your second hint is I would recommend calculating price improvement per trade. One of them is wrong. Desiree, I'm not using VS Code. Any reason why not? No. So in my first role out of college, I have a computer science degree. I was working at a consulting company that would modify and sell a Microsoft product, Microsoft Dynamics AX, which I don't believe exists anymore. And we were working in X++, which is not a real language. It's just for this Microsoft product. And after that role, when I started at Clearpool, our IDE of choice was Java, and Java was the language I had learned in college, so it was sort of a homecoming for me, and I just adapted to it. I've used it for so many years at this point that it's just easiest. Sometimes there's no better motivators than habit. So once more, if you're able to find the problem, you can solve it the hard code way, or you can solve it programmatically, and I encourage programmatic. Keep challenging yourself. And if you're not challenging yourself because this is pretty easy for you, congratulations, that's awesome. What questions can I answer for you? Either about the stock market, as far as I understand it, about problem solving, or anything else that might be interesting to you. Good question. How do you start debugging a code you have no clue about? Start with observations. There's always something you know. It might be very little, whether it's just what the service does, or maybe that's something you need to ask someone about. I would focus on the problems that have been reported and figuring out the source of truth that determines them. So like in the code that we're looking at, we're using a very simple if statement that has the correct scenarios calculated out and can just compare apples to apples, those numbers. So even if you had no other idea, I gave you a little bit of an intro at the beginning, but like if that wasn't enough or I hadn't done that at all, you could start there just by finding that actual error statement. Or if using like Kafka and like event-driven logging, you could like figure out where those events are created, where they're modified, and then backtrack from there. Look and see like, okay, it's this number. In this case, it's like the total price improvement. I think I called the variable. And you could backtrack of like, where's the set? I would always start with that. You always know something, and you're always capable of learning a lot more about any system, about any piece of code. So just constantly, again, this problem solving strategy is start with an observation, figure out what you're trying to learn, which is your hypothesis, determine how you can find it out, which in our case is debugging, but maybe if you're looking at code for the first time, it's just literally like, okay, like I expect that this method would return X value given this scenario. And then like, how do you prove it? And then keep adding those conclusions to your observations, like accumulate information. So you start with nothing, but you can find more. I hope that was a helpful answer. I'm gonna jump to, do you recommend using a debugger to learn code? That's a good question. I feel like when we were in school, we used, I remember Dr. Java as our original quote IDE, which didn't have a debugger. I do think it forces you to be more granular because you don't necessarily have the same tools in front of you to let you know when you're doing something wrong. That being said, I don't know that that's necessarily the best way. I feel like if you have a software engineering role, you're going to use an IDE, especially if you're a backend engineer, which I think was mentioned at the top, but like these are all backend situations. That's that's something you would use, right? You would have the debugger in front of you. So getting really skilled at using it is good in and of itself. Like when I was at Clearpool to start with, I did not understand what remote debugging was. But once I did, it was like the clouds had lifted. And I was like, oh, we can figure out any problem with remote debugging. So I think it's just a toss-up. You're a little more intuitive and detail-oriented with your code when you're looking at it without the debugger, but using a debugger in and of itself is a good skill set. I don't think I have an answer to this, but do any hedge funds make a lot of money without insider knowledge and using good algos? I don't know specifically about hedge funds, but do companies make a lot of money using algos? Yes. Keep in mind that, when you and I are trading, we're doing a couple of shares at a time because we're human beings and not corporate entities. But when corporate entities are buying and selling, they're doing it in massive quantities. So, if they're comfortable buying 200,000 shares of something and that price goes up a few cents and then they sell them, those cents add up. And that's what the algorithms do really well. They find either the discrepancies in cents or they are able to do something that we call sourcing liquidity, which is a bit much for today's discussion, but essentially it's like, where are their trades available and what's like the best price I can get for them? Can I grab them as fast as possible? Speed's also a thing. Being able to trade fast is a good quality. There's also a concept of rebates. So they do a lot of good things. Again, I don't think it's so much about insider knowledge, which is legal, as is just having optimization. It's the difference between if you check your Stash app twice a day, I'm going to plug my company, versus having somebody who's sitting and staring at numbers all day. All right, I went a little bit long without giving you the next hint, which I'm looking at, and is basically just to calculate each price improvement and figure out which one is wrong. I will tell you it's either the third or the fourth one. And we are coming up on the end of our third song. So we've got one more. And if you're already done, remember, programmatic solution. Find the optimized programmatic solution. I promise there is one. And also share in the chat for me something you're excited about this summer. I'm also excited to travel. I'm going to Greece in a few weeks. Got about 2 more minutes, and then I'll share the solution. If you don't want to hear it because you want to solve it on your own, feel free to mute me when I start talking, and I will wave frantically when I'm ready to start talking again without talking about the solution. But just keep in mind that you'll also see it on my screen. I didn't give a call out, but the third song was from the 6 Cast album, which is a musical that's opening on Broadway in September, which again, highly, highly recommend. All right, my song's wrapping up. There is one more song on the playlist. I don't think we need it. I think we'd rather go through the solution. I want to save some time for Q&A, so please feel free to put more questions in the chat, and I will get to them as soon as I am done demonstrating what a good solution to this scenario 3 looks like. But first and foremost, again, just like if you tried these, if you put them in your ID or you got on the the browser-based one, like give yourself a moment to be like, hey, like I tried. This was challenging. It was supposed to be. You're looking at somebody else's code. These are all new scenarios. For at least for the majority of you, it is awesome that you took the time to do it. And I am extremely glad that you did. So as a reward, and here's your moment, if you want to try to solve this one on your own, mute me and maybe don't look at this for the next couple minutes. So I'm going to share my screen again. And let's talk about scenario number 3. So we fixed the most obvious bugs. And now we need to figure out what is this last remaining issue. So I happen to know that it's this price improvement for trade. And even if I didn't know this, I would be able to come to it as part of my observation because I know that there's no issue with the quantity. And really, as you've probably determined, like everything in this class is really just comes down to this method. This is where all the juice is. This is where all the logic is. And the logic itself is all correct. I wouldn't have given you broken logic. That would have been pretty cruel. So a good way to go about this would be, especially because you have a limited number of inputs, would have been to calculate each price improvement and figure out which one is wrong. So if we look at, we're just going to jump ahead because I want to have a minute to answer questions. If we just jump ahead and say that I think it's a scenario, it's trade 4, that's incorrect. Is that right? No, it's trade 3. We're able to calculate what the price improvement for this is. So for trade 3, our price was $10.55. It happened at 43 seconds. So, sorry, I'm losing my brain. It is trade 4, that's incorrect. So $10.45. It happened at 45 seconds. So the quote that you should be using is this quote 17 because it's the one that happened immediately before. So our price improvement should be 0.3, right? Makes sense. Because that is this minus this. So we can go in here and see what calculation we're actually getting. So I'm going to, again, put a breakpoint here, but I'm going to take out the conditional part of it so that just always, actually, when trade.name equals trade 4, again, I'm just optimizing so that we can get through this. Remember I said the hour was going to go really fast? I wasn't lying. And I'm also just going to quickly comment these out so that I can get through this faster. Okay. So if I go and debug, and again, my observation is that we know it's price improvement. I was able to, oh, crumbs. Let me just take that out. I was able to calculate the price improvement numbers because I have them in front of me. So I'm able to determine which one is wrong. Don't be conditional. 2, 3, 4. So if I look here, my price improvement per trade is 0.24 instead of 0.3. Again, jumping a little bit ahead, the reason for this is this quote that's coming in isn't the right quote. And if I look at this method that gives us a quote, we see that we just loop through all of the quotes here. Now, the problem, which you could have found if you, again, got to this point and continued on, is that this scenario 3 quotes is a list. And if you know your lists, everything is ordered. So order is important, and we're iterating through. And these two are out of order, this quote 19 and this quote 18. So you might have figured that out. You're welcome to reverse the two of them. Although I will say that things coming in out of order is, again, something that was super real in the stock market. So what would be a fantastic solution to this? Here's the one that I did in the real world. So I'm just going to comment all of this out. Instead of using that quote loop that got us the quote that happened immediately before our trade, I'm going to make a tree map. And what I'm going to do is for each of the quotes, I'm going to do for each loop, quote. I need to make sure I filter out market sell price, return, because it's a for each loop. I'm just going to add them to the map. I'm going to add it based on the time and so what this gives us is a map which, one, has faster lookup than a list would, because for a list, if you're going through everything chronologically, you start at the beginning and you go through to the end, and there were usually at least 2 billion of these a day. So there's a lot. So if you're trying to find something later in the day, it would take forever. This gives us a much faster lookup because we can do this call where we say return map floor entry based on. Oops.
Hey, Kelly.
Yeah, I know, we're just about there.
Yeah, it's time to wrap up. You did really good.
Value of trade time. Get value. I went through that pretty fast. As I said, I knew we were going to run out of a little bit of time. Workshops go really quick. Let me quickly, just trust me that that one's correct because we're going to wrap up. And just wanted to share my takeaways. So 1, keep thinking about your problem-solving strategy. It's helpful both as you want to progress through your career, but then also if you are, in an interview and you want to be talking about how you go through something, it's much more effective to be able to describe a process that you've been thoughtful about than it is to just say, oh, no, I just figured it out. That's much more impressive, and it's going to help you a lot as you continue moving through your career. Learn more about investing. If you're interested in SASH, please get in touch. We're always hiring. I love Investopedia. I also shouted out the NYC FinTech Women Group, which is a fantastic resource. Get in touch with me. My website's there, and all of my links are on there. So my LinkedIn, my email, my Instagram, anything I have. If you have any feedback on this, I would love to hear from you about it. And finally, check out Women Who Code NYC. I'm always there. We have lots of really fantastic events. Yeah, and with that, thank you so much for taking the time. Thank you for practicing with me. I hope that you enjoyed yourself. I hope that this was somewhat fun, at least, and that you learned some things. And yeah, with that, I guess I'm done. Surya?
It was really, really great, and like 1 hour flew past by like really quickly, and hope everyone learned a lot, and you did amazing.
Oh, thank you.
Thank you, everyone.
I'll talk to everyone soon. Have a great rest of the conference.